R is the region bounded by y is equal to 1 minus x squared and y is equal to 0 about the x-axis, okay? So we are going to draw first a graph, okay? So, oops. We have a graph and we need to sketch out the y is equal to 1 minus x squared. So this is 1, this is 1, this is negative 1. And then it looks like a upside down x squared, because it is. And then we also have the y is equal to 0. And those are bounded together, which means this shaded portion is rotating around the x-axis, making a 3D object. And the volume is what we are going to find out. Okay, so now problems like this, I like to use the disk method, disks. Okay, and what the disks method is, I draw a disk, obviously. Okay, I draw a disk like this, and it's a 3D one. So, okay. You guys can't really see this well, so I will draw another disk that's a bigger size. So this is a disk we have. And this, right, like very tiny length is equal to dx. Because this is in terms of like the horizontal line. And horizontal line, that's the, oops, x-axis. So yes, this is going to be dx. And we will try to find the area of this circle. Well, first we're gonna have to find the radius, okay? Which the radius is equal to y, okay? Oops, y. But the value of y is equal to 1 minus x squared, right? That's no problem. We can just, write down pi times 1 minus x squared, and then dx. And we just found the volume of this disk. Okay, but we need to pull in the integral from 1 to negative 1. So 1 to negative 1. So we have infinitely, not really infinitely, but very many of disks, okay, in different sizes that will fill this thing up. So here's an equation that we have to find. Okay, the pi can come out because that's a coefficient. And also, negative 1 can just disappear. And I can just put a 0. Instead, I can multiply 2. Because originally, what we had is 1 to negative 1. Okay, so here to here, and then we put many disks. But since I did it 1 to 0, I have to multiply 2 to make things even. But in this way, it's better because I don't have a negative 1. And that's better, okay? And that's a fact too. So now let's expand this. If we do, we get 1 minus 2 times x to the power of 2 plus x to the power of 4 times dx. And when I integral this, I get 2 times pi times x minus 2 over 3 times x to the power of 3 plus x to the power of 5 over 5. And we still have the interval from 1 to 0. The 0 I can just ignore because when I just put in the 0 there, everything's going to be 0. So yeah. And then when I put in the 1, that makes everything interesting because I get 1 minus 2 over 3 plus 1 over 5. And numbers that are inside the parentheses, okay, let's bring all of this over here. 2 pi can stay the same, and 1, I will change it to 15 over 15, and then 2 over 3 to 10 over 15, and 1 over 5 to plus 1 over 15. Actually, that's 3. Okay, all of that is equal to 2 pi times, 8 over 15, and that is equal to 16 over 15 times pi. Yay. So the video ends right now. Bye.